Hey everyone, and welcome. Today, we're tackling a neat linked list problem called delete nodes from a linked list present in an array. It's a classic task that's great for understanding how to manipulate pointers. Let's break it down together. So here's the goal. We're given two things, a regular list of numbers, which we'll call nums, and the head of a linked list. Our job is to go through the linked list and remove any node whose value appears in that nums list. Finally, we need to return the head of the modified, shorter linked list. Let's look at an example to make this super clear. Imagine our nums list contains the numbers 1, 2, and 3. This is our delete list. The linked list we're given is 1, pointing to 2, then 3, 4, and 5. So we start at the head of the list. The first node has a value of 1. Is 1 in our delete list? Yes, it is. So we need to get rid of it. The next node is 2. That's also in our list, so it has to go. Same for node 3. Once we remove 1, 2, and 3, the first node we're keeping is 4. This means our new head of the list is now the node with the value 4. After that, we keep the node 5. The final result is a list containing just 4 pointing to 5. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. The logic is the same everywhere. I'll be showing the full code for Java, C++, and JavaScript towards the end of the video. So what's a good way to approach this? A simple but slow idea would be to check every node's value against the entire nums array. But that's inefficient. For every single node in our linked list, we'd have to loop through the nums array. A much better way is to first convert our nums array into a hash set. This is a super important optimization. Why? Because checking if an item exists in a hash set is incredibly fast. It's practically instantaneous. This will be the foundation of our efficient solution. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first, and don't worry after that, we'll walk through the most important sections together. Alright, here's the Python code for our hash set approach. It might look a little tricky, especially with the two separate loops, but each part has a very specific job. Let's break it down. First things first, we do exactly what we planned. We take the input list of numbers, the one called nums, and immediately convert it into a set, which we can call values to remove. This single line is what makes our whole algorithm fast. Now this next part is really important. The head of the linked list is a special case. Why? Because there's no node before it. If we need to delete the head, we can't just tell a previous node to skip over it. So we have a special loop, just for the beginning of the list. It says, as long as the head exists, and its value is in our set of values to remove, just move the head pointer to the next node. We keep doing this until we find a head that we want to keep, or until the list becomes empty. This brings up an interesting edge case. What if our nums list contains the values of every node in the linked list? Well, that first loop we just saw would run until the very end, and our head variable would end up being none. This little check right here handles that perfectly. If the head is none, it means we deleted everything, so we just return none, which represents an empty list. Okay, now that we have a guaranteed good head, we can handle the rest of the list. We set a new pointer, let's call it current, to start at our valid head. Now notice the logic here. We don't check the current node. Instead, we look ahead to the next node. We ask, is the value of current.next in our set of values to remove? If it is, we bypass it. We set the current node's next pointer to point to its next node, effectively cutting the middle one out. If the next node is fine and we want to keep it, we just move our current pointer forward one step. We repeat this until we reach the end of the list. So how efficient is this? For time complexity, it's big O of m plus n. M is the number of items in the nums array, which is the time it takes to build our set. And n is the number of nodes in the linked list, which we have to visit once. For space complexity, it's big O of m. This is because we need extra space to store the values from the nums array in our hash set. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can see the logic is identical. Create a hash set, handle the heads separately, and then iterate through the rest of the list. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. We use an unordered underscore set for the same efficient lookup. The pointer logic remains exactly the same. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. We create a set from the nums array, and the rest of the implementation follows the same pattern we've already discussed. Hopefully, seeing it in a few different languages helps solidify the concepts. So let's wrap it up. The 3 big ideas from this problem are: first, always think about using a hash set when you need to do many fast lookups. Second, remember that the head of a linked list is often a special case because it has no node before it. And third, the standard way to delete a node in the middle of a list is to use a pointer to the node before it and rewire that node's next pointer. Alright, before we jump into the other languages, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.